Hi, my name is Navarun Biswas from IIT Kharagpur. Today I will teach you nucleophilic addition of the carbonyl compounds. So basically it will be the carbonyl reduction via hydride donor. So what are the nucleophile? Nucleophile are the electron rich source. So it will be like a fluoride minus, chloride minus, let's say alkoxide O minus. So they are the nucleophile. So sodium hydride, the hydride is the nucleophile, and the Greek reagent CH3 also the nucleophile, and then the ammonia lone pair. So double bond, triple bond. So they are the nucleophile. So basically we will focus on the fluoride and the hydride also. Sorry. So what is the addition? The addition is the, let's say a nucleophile is the reactant, and addition the reaction of the fluoride or the O minus to that particular molecule. So that will be the addition. Let's give an example, then we can very clear. So this is the, let's say, cis-butene. If we give cis-butene in platinum catalyst, so this will like give this product. So this is the one type of addition. So in this case, our addition will be on the carbonyl compounds. Let's say this is the carbonyl compounds. This is the carbonyl compounds. From that, we will make this type of product. Nucleophilic addition. Let's say these are the carbonyl compounds, and this is the product. So have you found that the nucleophile is attached in this compound? So from this compound, the new bond is generated. So in here also, this is the only addition type reaction. But here is a nucleophile also, and there is a connected bond also, new bond generated. So this is like the addition of the nucleophile. So we can say this is a one type of nucleophilic addition. So in this case, we will go through like lithium borohydride, sodium borohydride, lithium aluminum hydride, like let's say BH3. So what are the uses of this product? So how they reduces this type of carbonyl compounds? Carbonyl compounds and this system also. What are the changes we have observed? So in addition reactions, we can tell that these two carbon, these are the sp2 hybrids, these are the planar molecule, and this is 120 degree angle. From this is like a simple alkane chain, sp3 tetrahedral and 109 degree. In same case also happens here. Let's say this is also sp2 planar 120 degree. Same this sp3 also tetrahedral also 109 degree also. So this is the addition reaction features. So this feature will include also here. So first of all, we have to consider what happens. One thing you have to understand, there is a one pi bond also. So one pi bond and there is a one sigma bond. So this is a 2 sigma bond new generated. In here cases, let's say one pi bond vanishes and one sigma bond new generated. These are the unique feature. Unique feature is sp3 carbon will produce, let's say, one or like a sigma bond will produce. These are the addition reaction features. These are the addition reaction features. As we know, the nucleophile approaches the carbonyl center. How the nucleophile approaches the carbonyl center, that is the very important thing. So let's say these are the nucleophile. So here there is a nucleophile HOMO. So this will attack on the pi star because mainly in this system all are intact. All are intact except this pi one. This is not intact after the reaction. So we will talk about this pi one, only this pi one. So the nucleophile attack on this pi star of this carboxy double bond O, and this result a new thing that the nucleophile approaches like a something big angle. So predominantly we know this carbonyl will attack like this, and after the product will like this. That is not the true thing. The true thing is it will like a bend. Why this is bend? Because in this carbonyl and oxygen, this is a carbon and oxygen, there is a very high electron source. The HOMO of the nucleophile and the electron rich source of this carbonyl or oxygen bond this will repulsion very highly. That higher repulsion makes slightly bend. The nucleophile will attack slightly bend. Let's say this is the carbonyl compound on my hand in planar. The hydrogen will attack slightly bend. That can very feasible for the reaction. We have previously seen how the hydride or the nucleophile attack on the carbon center. Now we will see like how a hydride can use this. So let's say we will talk about sodium hydride. The sodium hydride is a rich of sodium plus and H minus. So mainly we have seen H plus also. So here you will see the H minus. This is very important, and this will operate or enhance the reaction of the carbonyl compound. So for this, what are the hydride minus? Hydride minus are the like fully one is orbital filled, and other thing is very ideal in size. If you see like a hydride minus very ideal in size. How this happens? So hydride minus first it will act as a base. So if there is any base, acidic compound, first will abstract the proton. If there is no like a proton thing, then it will act on the carbonyl compound. That is the most important thing. Why it will act as a base? So let's say ETOH. The hydride minus will interact the pi star of this bond and then interact of this hydrogen. So for this hydrogen, this will abstract the proton of the ethanol, and this makes like this type of molecule. Why it cannot penetrate, let's say, oxygen or something like that? Because in the oxygen there is a highly 2p big orbital, and it cannot diffuse the big orbital of the 2p shell of the oxygen. So that's why it will first act as a like a base. Let's say not ethanol, let's say carbonyl compound. Why the sodium hydride is not like act as a nucleophile for this? Because it cannot diffuse the 2p orbital. So apart from this, these are just like a basic thing we arrived to. So you can remember or not remember, that's not important. But apart from this, you can understand what will be the topic and what are the understanding it will be used for the next step. So for this, up to you have to remember some reagents: sodium borohydride, lithium borohydride, lithium aluminum hydride, BH3. So these are the mostly useful reagents. From this, you have to be understand what will be the product of the carbonyl compounds. First of all, we will talk about the simplest on sodium borohydride. How the sodium borohydride attacks on the carbonyl compounds. What are the carbonyl compounds are there? So what are the derivatives of the borohydride? So first of all, we will talk about this sodium borohydride. So how the sodium borohydride looks like? The sodium borohydride looks like this is the sodium borohydride. So how you make sodium borohydride? It's a very simple reaction. I think you have gone through like in inorganic section. So sodium borohydride is like a borane, diborane. When you will heat the diborane with, let's say, sodium hydride, that's why I am talking about sodium hydride previously, it will produces 2 Na B H and H, and there is a negative charge and there is a positive charge. So now the borane is like an octet filler. Before the borane, like BH3 has a 6 valence electron. In this case, this is a, if you see the structure, this is a banana bond. Have you understand where the borane comes? This is the banana bond, 3 center 2 electron bond. You will get it in our inorganic section. So from this we will talk about how we will produce the sodium borohydride. Then how we will introduce the carbonyl compounds on the sodium borohydride. We will talk about the carbonyl compounds. So what are the carbonyl compounds are there? So there are like a aldehyde, ketone, ester, amide, this is the acid. So you just remember this order. This order will help you in a long term very good way. How? We will tell afterwards. So in this case, if we say these are the generalized reaction, highly reactive way. First the aldehyde, then ketone, then ester, then amide, then acid. These are the reactive order. The highest reaction order will be like aldehyde, then if there is a ketone, then ester, then amide, then acid. So first we will introduce the sodium borohydride, how this happens. So you have to be very considerate about this. From this lecture we will use how we reduce the carbonyl compounds and their derivatives. So let's say aldehyde. We will use different color to understand why we will use different color. We will change some other color, let's say blue or like a light blue. Sodium borohydride. So how this reaction happens? Here we see this is a nucleophile. You don't understand this is a nucleophile. That is the wrong thing. In their hydrogen there is a 2 electron, boron and hydrogen. That hydrogen will take as a hydride and that hydride will attack on this carbonyl center. On that carbonyl center it will attack and this will form as a this type of product. And this blue hydrogen, now see the blue hydrogen will attack like a intact in this compound. So what we have understand? We have understand that one pi bond loss. Here we observe one sigma bond we get. So for that the O- is a very reactive species. Now the boron will like a BH3, very neutral molecule. Now this happens that this O- attack on that boron and makes a this type of derivative. O BH3. So here we see there is one hydrogen also there. So there are in the molecule there are millions and billions of aldehyde there. So it will attack. Let's say it will attack against a new aldehyde. So with color will different color. Let's say red. So it will attack on a different aldehyde. Let's say it is red. Then it will attack on this compound and makes like this type of product ROBH2 and here we get the new product So here are the new products. So as we know, so there are 2 hydrogens also left. This step, this will not step. This will do the another step. Let's say this will do another step, and this will make the product like OB. So same species. If you see these are the same species, this is the same species, just colors are different. So for aldehyde it will reduce. So you have to be considered one sodium borohydride can reduce 4 aldehyde. So after this, if we add MEOH or like any protein solvent like MEOH or ETOH or water. This will just hydrolyze this bond, and the product will like, let's say we will use the color. Let's say color code will be very used. So let's say we will use H2O. H2O. So the molecule will be like this type. R O. There will be blue color H. So as we see that this water protons comes here, this borohydride proton, let's say this borohydride hydride comes here. So have you seen what are the observers? So these are the rough mechanism. So you don't go through the rough mechanism, just you go to understand what are the H product. If I summarize the product of all of the thing, what will be the result? Let's say if I summarize, R O H gives, we will use the different color, sodium borohydride, and we will use the different color of H2O. R O. Let's say we will first use the sodium borohydride. For the red color, we will use this. Sorry, this is the green color. So this will product like this, and the blue color will be like. So always the alcohol proton will be come from any protic solvent, and the carbonyl compound of the proton, or let's say the hydrogen, will come from the borohydride complex. Okay, so this is the borohydride. The same thing happens also like ketone. Like let's say we will see the example of the ketone. R O H goes same conditions. Let's say same condition. The product will be like this. So if we color the things, the color will be like this thing, and the color will be like other same thing, same for the ketone and the aldehyde. These are the most important thing. So after this we will go through the other two, lithium borohydride and lithium aluminum hydride. These are the carbonyl compound, different type of variations, and these are the borohydride, some derivative of the borohydride. So who will reduce whom? That is the main fundamental questions. So if you see the questions, so this sodium borohydride has the potential to reduce aldehyde as well as ketone. The lithium borohydride is little bit more powerful. Why this is little bit more powerful? So as we know in the periodic table, this zone, this uppermost zone will be the highly electropositive character. So what is the electropositive character? Let's say lithium hydroxide. In this sphere area, the partial positive charge of the lithium is very high. For the very high, the electron will be the repel on this zone. So the maximum repel, the maximum electron will found in this area. For this portion, for the lithium or sodium or aluminium, this has the most highly electropositive character. The topmost is always a lithium. So for this reason, this is the most electron rich center. More electron rich center. For this will be the more reactive than the sodium borohydride. Have you seen? Sodium is replaced with lithium. So as we say that lithium is more electropositive character. So that's why this happens. The lithium borohydride can do up to this. Okay. So if both the cases, this will give like this type of product, this will give like this type of product, this will give like a alcohol simple quantity alcohol type product. How this happen? So we will use the mechanism. First of all, in this case, let's say R O R. As I know, the lithium borohydride attacks. So as usual, how the attacks happen? It's open. After this, there is a one tetrahedral intermediate. OR. So when the O minus can come back again, the OR is a very living group like OET, O minus, or like any other living group. This will make this product like this. After this, you know the aldehyde is much more reactive than the ester. So there are like other type of lithium borohydride. Let's say there are like 1,000 crores and crores, billions of billions lithium borohydride. So it will act like, as a like previous thing which we have earlier used. How the sodium borohydride attacks, same way the lithium borohydride attack on that aldehyde and makes the product like this. It is the same mechanism. That's why I am telling mechanism important for remembering how this happens. And the product is the main important. After the mechanism, how you remember the product, that is the main thing for this. The lithium aluminum hydride also give same product like this. But there is a twist also. This lithium aluminum hydride gives this product like as this, and this product like as it gives as this. How this happens? Let's say first we will talk about the carboxylic part, because carboxylic part is a very important, very easy to understand. So sorry. Let's say this is the acid part. So first, in my first intro, I have seen that okay, this is the acid carbonyl part. We will make this a product. Okay, this is like this is not the correct. So first I have told H minus will act as a first base. So if their base, like if their acidic proton is there, it will act as a on the acidic proton. Then after the acidic proton is removed, then it will do some other further reaction. So in this reaction, there is the first criteria is acidic proton. It will abstract the acidic proton and makes like a carboxylate ion, and the carboxylate ion is like this type of. So and this will be like a very not reactive after this. So this will be the main. For that we have to understand the mechanism of the lithium aluminum hydride on the amide carbonyl. So this is the amide, and this is react on lithium aluminum hydride. So how this happens, lithium aluminum hydride? So let's say AlH4 minus, it will attack on that carbonyl center as we see previously. Then O minus, Na2, and there is a hydrogen also. And this O minus will coordinate like a, now the AlH3, it will coordinate like this, and this will make this product AlH3, let's say H2 and H NR2, there is a hydrogen. So now the NR2 will, there is a lone pair of the nitrogen. This will give on this bond, and the O minus will be removed out. So what will be the product? The product will be like NR2 positive. There is a lots of aluminum hydride. So AlH4 will now again attack on this imine bond. This is a new thing, imine bond. This imine bond will reduce. After this will product. Okay. Let's say we are using NR2. So this. So the main funda like amide to this product is basically this way, it will go through this out. So this is the lithium aluminum hydride we have done. So what is the role of the other reagents. The other reagents we have now borohydride. So we'll look it up. Term is the borohydride. So these three terms, up to these three, it cannot be. Borohydride cannot reduce aldehyde, ketone or ester. But there is a strong affinity of also this and this acid. How this happens, we will go through this. So first of all, amide again. Amide we are using. So how the mechanism happens, you just remember. If there is any tough topic, tough question come, if you go through the mechanism, you can do whatever you can do. On that case, you have to understand how the mechanism works. So this oxygen is giving the electron to the boron, and instantly boron has a hydride. So this hydride will give this in the carbonyl center and makes a like this type of BH2 HAR2. So as we see in the previous case also, now the nitrogen electron pair will give the on this bond. After this bond, the now the boron was there. So here the electron, the double bond electron attract on the boron. As a result, boron has a now 4 tetravalent. Now the tetravalent boron release the hydride and makes this a product like a, let's say we will color the coding. Let's say hydride will be like a red color. Red color will be given. So AR2 is a previous hydrogen and there is a now red color hydrogen. Now there is a one thing you have to understand. There is a BH2 there. How you remove? The simple thing, if you iodize with H2O, quenching the reaction with H2O, this will give, this is the not BH2, it's a AR2 system. Now the reaction looks like a this. So if you observe the reaction, boron and the lithium aluminum hydride give the same product of two systems. So in this case, borohydride will use. So another case, borohydride will use on the carboxylic acid. So how the carboxylic behaves differently, we will see this. Let's say this is the acid. This is boron. So this is much more nucleophilic. This will attack on the boron. As a result, BH3 this happens. So the lone pair will push on this bond and the oxygen will neutralize. If the oxygen will neutralize but the boron is still negative, so what now happens? This from the boron, it will produces a hydride and abstract the acidic proton. The first thing I have told, if there is any acidic proton term, all time the hydride will take the acidic proton. Then after the reaction will go proceed. So after this, if this acidic proton takes, this will make the hydrogen gas and it will neutralize and the product will look like a this. So this is a one step, but there are another acid also. So another acid also do the same step. So after 3 steps, because at this there is a boron has a 3 center, So after this, the compound will look like this type of system. It's a triangle. So after there is again borohydride will come. How this borohydride come? It will show with the color. So after there is again highly more nucleophilic than this. So it will attack on the borohydride again. This will make this product like a and this will produce the hydride. As a result, it will make BH2OB. There is a hydrogen. So after this, and now the lone pair will push on this bond, and this O negative will be produced, and this O negative will coordinate this BH2. So this reaction will produce ROH. But we know in this case borohydride is not there, only borane is there. How it will reduce the aldehyde? This is the main topic I have to tell. So as usual, the reaction goes that way, that the oxygen will coordinate to bonded, and this will BH3. So this will produce the hydride and attack on the carbonyl center. As a result, BH2, H and the H. So if we see same way as sodium borohydride is reacting, same way this also reacting. So after there is a H2 or like ethanol, ROH is produced. So this is the most fundamental reactions of this. So if we summarize what we have understood, sodium borohydride will do aldehyde and ketone reduction to alcohol. Lithium borohydride do aldehyde, ketone as well as ester. Lithium aluminum hydride do these three also, ester, aldehyde, ketone. But there is a amide reduction, and borohydride, let's say not borohydride, let's say borane, BH3 will do only amide and acid. There are some other reagent, useful reagent like diode will reduce only ester, diol H will reduce ester to aldehyde. This is a very good popular reaction, and this will stop here. No further reaction. If there is some conditions applied, like let's say 0 degree Celsius, let's say somewhere you have seen 0 degree Celsius and like a very strong reducing agent, at that case you have to be considered, okay, the reaction will stop in this phase. So these are the reactions we have to be answered. So for this we are practicing some new questions. Some questions what will be like this type of things. These are the questions, very popular questions. How we will make this? So for the question purpose, this is like just like the hydrogenation. Let's say Adam catalyst, H2, PTO2 you can use. For this is the very important, and this also very important. So if we use sodium borohydride, the sodium borohydride directly reduce this portion also and the ketone portion also. Double bond will reduce to the single bond, and ketone will reduce to alcohol. So how? So borohydride is like a very soft nucleophile. So first it will approach this position and make the single bond. After this, there is a still there is a carbonyl center was there. For that, it will reduce this. So this is the main important. How will reduce this? So this is one reaction: sodium borohydride and selenium chloride. So how this happen? This sodium borohydride coordinates to selenium chloride and makes like a heart center. So sodium borohydride and selenium chloride makes the heart center. Heart center. So for that heart center, it will approach this center first. So this center will be the most targeting center. Most, at least 97% will be this product. Okay. So these are the reaction. One reaction there is in this 2025 NEET 2025 case that NEET 2025. So how you will make this? So this type of one question comes of divergence. I have teach you how the divergence reduce the aldehyde. So this type of one question you have to answer. So if there is any problem, you just contact me. Okay. Thank you for the visiting the slides and the visiting the class. So thank you for me. Okay.